Yeah, so good morning everyone. So today we'll be discussing about innovations in glass and how the overall facades of the future is going to be. So agenda for the today would be covering the innovations in the glass facades, basically covering the three important innovations in the glass industry in terms of the facades, electrochromic glass facades, and I'll talk about the introduction of the product and the applications for it, switchable and the projectable glass, some of the introductions, and I will talk about some of the applications for the product as well, and the designer facades, which is the trend for the today, and then we'll be talking about introduction and the applications of this product category as well. And then finally I will summarize in my presentation how these three products can be used in this entire glass industry. So just to bring about why the glass, setting up the context, why the glass is increasingly used in this construction industry. First and the primitive is the natural daylight. So glass, because brings in a lot of natural daylight, so that's the first big reason why the glass is being used in the construction industry. Second is to have a connection to the outdoors, and third is to make the buildings modern. So these are the three basic reasons why generally you would be using the glass in the first place, and I'll be actually covering one by one each of them, how these can be actually explained in each of their reasons. So let us talk about the first reason, natural daylight. So why this natural daylight matters for health and well-being. So there is a psychological explanation which I am actually going to tell you. So there has been a recent discovery in finding out that these new light sensitive cells are responsible for creating non-visual effects, and it actually have a large impact in terms of the biological function of a human being. So be it a sleep or a wake cycle regulation, mood, memory, alertiveness, cognitive functions, and there are so many things which actually this non-visual effects brings about impact on us. So if you look at the exposure to the natural light is the biggest trigger for all these mechanisms, and it is called that it actually synchronizes the internal clock of a human being, which also includes all those positive effects on the health and the general well-being of a human being. So these are some of the effects which a daylight will actually create on a human being. Now let us find out some benefits of the views which actually create on a which help us a human being when you generally use a glass. So views to the nature are usually preferred and particularly beneficial. It's a effect which is called a restorative effect, which has been studied by a lot of these scientists and some of these architects as well, which actually proves that views will actually create lot of impact on a human being. So views are more valued than natural daylight. So this is also one of the things which has kind of come up with these kind of studies, that views matters more than as compared to a natural daylight. And some of the interesting views may elevate the other issues. Some of them can be glare and all those issues which actually come up by using the glass. So those issues are covered with the interesting views. So daylight alone without a viewing content would not bring some of the benefits which is important for a human being. So if you look at the two important aspects which I have discussed are the views and the daylight. So all these 2 points have a larger impact on the human beings. So views matter. Let us talk about some biological and psychological explanations for it, that it brings refocus for a human being and relaxes eyes. It satisfies the need of both escape and feeling of safety. It helps you to stay connected to the world and access to the environmental information, and it restores the overall experience. So if you see, views actually matter. So the most important thing which I am actually trying to say is that views matters for a human being. So some of the studies which have been done in this green building, if you look at this study which has been done in this green buildings, it actually clearly states that these effects are far larger than the tangible effects of having in building, which actually allows you to have views and daylight. So if you look at the first impact which is mentioned is the memory and the mental function of students. So if you look at the universities which are being made green buildings and which have used daylighting and views as their important criteria, so they are able to perform 10 to 25% better in these green buildings, and these students increases their memory in form of being able to perform better in their evaluations. In terms of the cell processing for call processing for these BPO employees, if you look at these buildings which actually allows, these are not the boxes of insulated material, these are glass buildings, so it actually allows them to process the calls faster. In terms of if you look at the healthcare as an industry, so it has been actually proven that people who get access to the outside views in hospitals, they are actually curing faster, which is almost like their stays goes 8.5% shorter. I'm not sure if it is very good for the hospitals as in business per se, but it definitely helps the patients to recover more faster in these kind of buildings, which actually allows you to have outside views. In terms of the daylights, if you look at daylight is actually helping the students to secure high numbers. So institutions would be very interested in actually providing proper daylight to the students, which actually helps them scoring higher grades. And if you look at the grades have gone from 5 to 14% higher, and they learn, their capacity of learning becomes faster, more to 20 to 26% if they get proper daylight in their campuses. In terms of the workforce, students and in terms of the people who are working in the offices, their productivity increases by almost 18%, which is a large number in terms of the overall productivity of the people. And just to mention you that the absenteeism also goes down when you are actually working in these kind of spaces, which are green spaces which gets natural daylight throughout the day. So overall productivity of the people increases by almost 18%, which has been proved in this study by the World Green Building Council. So even if you look at these retail outlets, so they get increase in their sales if they are actually allowing the people who are coming into their stores, their consumers, to have natural daylight to the entire day. In terms of the improvement in the systems overall, as in tangible improvement, is that you get a better efficient daylighting, which is almost like 23% productivity is increased by that. And then if you have a better ventilation, the productivity overall improvement is almost 11%. So if you look at the percentages in terms of the impact of the outer views and the natural daylight is a very high impact in all these kind of buildings. So we have talked about a lot in terms of the the better or the good impact of natural daylight and views, and by using the glass you get the both of these two important parameters. But that's not only the issue which comes with the glass. So there are two basic and very challenging parameters which are actually related to the glass and which comes with the glass as a building material, is heat and glare. And this heat and glare can counteract the positive benefits of the daylighting and the views. So if you look at in terms of let us go back to the solution for it. So if you look at in the ancient times, the first form of sun shading actually started a long time ago with animal skins which are spanned prior to the dwellings, and this were actually to stop the glare and the heat which was coming from the sun. So this was the first type of sun shading which was actually made available to the human being, to the human race. The second which actually came in the existence in the ancient times was atria, which was especially done in the Mediterranean regions, wherein they were actually using this kind of method to actually provide sunshade to the human beings. So the history of sunshading is quite old, and then we have moved ahead in terms of year on year in terms of the sunshading. So later then you look at the celosias in the Arabic regions, the awnings which came in, and they provide a very good amount of sunshading to the interiors. So if you look at year on year, so there has been very large improvement or advancement in terms of the newer sunshading options. And in the 20th century, we see that now we have slats, curtains, awnings, blinds, shutters. So there are a lot of new new technology, new products which has helped in terms of giving the sun shading. Now when we talk about this 21st century, we are looking forward for these kind of blinds, rollers, shutters, shading devices, and when we use them, so that's the view what we see from inside. So you imagine if you have used the glass as the first place, then you are actually defeating the overall purpose of putting up the blind. And this is the view from inside, that when you put on the blind, and this is from the outside. So the first basic purpose of using the glass at the first place gets defeated by actually putting up the blind in the first place. So the glass was used to have view, to have natural daylight, but it gets defeated then by using the blinds. And there has been a study which has actually proven that once you put up blind, or somebody sitting next to the glass puts up the blind in a day, it is going to sustain, or it is going to stay for that entire day. So this has been proved 90% of the times people who is sitting next to the glass, he finds heat and glare, and then he actually put on the blind, and then you are not able to, then it's not being lifted up through the entire day. So that's the question mark which actually comes in from the designer's point of view, from the architectural point of view, from the construction industry point of view, that why you're using the glass in the first place. So there is a reason why the building has why the building is made with windows, and for that matter is not to showcase these beautiful blinds which are generally used. So it is actually for viewing and connection to the outdoors. So we have a solution which is called electrochromic glass. So this is a glass which actually tints on demand. So imagine this as a technology. When we look at in terms of the first technology which was there in the market was a photochromatic lens. So this photochromatic lens is a passive tinting technology, wherein a person who goes outside in the sun, so that this glass gets tinted because of the sun falling on the glass. So now this is a same process of an active tinting, wherein we actually give the current to the glass, and then glass gets tinted based upon the electricity supplied to the glass. So this is as a technology is called as an electrochromic glass, which actually gets tinted on demand. So if you look at it, this is a general office space situation, wherein a person who is sitting next to the glass, he is not able to sit next to the computer because there is a lot of glare condition which happens. And imagine we have almost like 1.5 lakh lux outside, and you know that how much we need for working or for studying or for being in a living space is not more than 1000 lux. So imagine that 1 lakh lux or 1.5 lakh lux which is falling directly on the glass, and it is allowing even for the matter 25% of the light. So it is actually going to create glare condition, and because of this glare condition, people who are sitting next to the glass put on the blind, and this is a typical office situation which happens every time. So because of this, then you don't know that why the glass was used in the first place. So it was used that you get natural daylight and to have the connection to outdoors, and this is a typical situation which happens. So now with this newer technology, which is a very high innovation which has happened as an industry, is this electrochromic glass, and how it can actually change this entire office space. I would like to showcase it to you. So if you see this picture, this is a typical scenario. Now I will actually put up a electrochromic glass here, and this is how the situation of the office will change, and you will have a transparent heat and glare control system. Now if you look at this image, this actually clearly tells you how this blinds, moving parts, shadings, roller systems, automated louvers, all those things can be actually removed, and the glass is going to perform as one material which is going to do all the functions which is required for controlling heat and glare, most importantly keeping up the daylight and the views. So this is how this electrochromic glass can actually change the way you look through the glass. So this is a next level technology which is happening in this product itself, is the Inpain Zoning. This is as a technology is an ultimate comfort giving technology, because what it does is that you can actually divide a single pane of glass into up to 3 zones, which are these light zones. So what these light zones can do for you is, then imagine that you have a grid of 3.8 meters floor to ceiling height, and then you divide it in a vision panel of 3 meters, and then you can have a spandrel panel of for example some 0.8 meters. Then you can actually divide this entire vision panel up to 3 zones, and let me tell you that it doesn't have any vertical members in between. It's only the glass, it's a single glass which can be actually divided into 3 parts, maximum up to 3 parts, and then it helps you in terms of controlling the glare. So your glare will be controlled completely. You will have a natural daylight throughout the day, and you will have a flexibility in terms of controlling each of these zones. So if you look at this picture, the sun is at the top zone. So in the top zone, it is actually it is at the tinted state, and at the lower zones it is at a more clearer states. So that's how this glass can be controlled with different tinting zones. I'll explain you how this tinting zone is actually being controlled. So this is a typical situation wherein you understand. This is an important slide for this session, that how you see that how this glass is being selected particularly. So the glass is selected on the two basic and important parameters, which is the light transmission, so amount of light which is coming through the glass, and the SHGC, which is the solar heat gain coefficient, which is the heat gain which you are getting from the sun. So if you look at these two parameters, which are the defining parameters in terms of the selection of the glass, so if you look at the the solutions which are available right now in the construction industry with the glass, you have gone from a first generation of coated products to a fifth generation of coated products. So if you look at the hard coated reflective products which are available right now in the market at a quite an affordable prices, and which were used in affordable housing projects, so these have light transmission in the range of, these are dark glasses, so it has a light transmission in the range of 5 to 10% with a heat gain of around 15%. So that's the basic solution which is available right now at a very affordable cost. Now if you look at going towards the high performance buildings, the buildings which are green compliance, buildings which are green rated, buildings which conserves large amount of energy. So from there we can actually go towards the products which are low E products, double silver coated products. And if you look at this low E E3 which is mentioned in this slide, so this has an approximately some 50 to 60% of light transmission and has a heat gain of 0.3 to 0.4. So which is almost like creating a double silver coated glass which has a light transmission ranging from 60 to 50% with the heat coming in of around 40%. So that's how the solutions which are available right now. So low E2 which you see in this picture is also a product wherein you can have a light transmission up to 70% with a heat gain of around 0.5. So the products which are available with us has a selectivity of 2. So let me define you what is selectivity. So selectivity is the amount of light which is coming in vis-a-vis the ratio of the heat which is coming in. So the products which are available with us right now has a selectivity of around 2, which are fifth generation of the products. And with this selectivity of the product, we are able to control the light and the heat by 50-50 ratio. So imagine, this is the solution which is available with us, and then we are talking about reflective, highly reflective glasses which can go up to a heat gain of, for an example, 0.15, which will become too dark. So now I can actually, we can offer you as a technology which is available, which can give you best of both of the worlds. So we are talking about a technology which can actually, create a spectrum of the light transmission against the heat gain. So imagine now this technology or this product can actually give you a light transmission of 60% and an SHGC or a heat gain of 40% or 0.4. So now the magic will start. Then you can actually start tinting the product, and then the first stage can be tinted up to 18%. The second stage can be tinted up to 6%, and the last stage is 1%. Imagine what 1% is a very, very, it's almost like a blackout situation which is being created in the glass, and it has an SHGC of 0.09. So the SHGC of 0.09 is a thing which is almost like you're talking about making a brick wall, and then you are still able to see from inside to outside. So you're not stopping the views, and you are still able to conserve the glare part of it, and then you are able to see from inside to outside. So this is the spectrum which a electrochromic glass can offer, which is like from light transmission ranging from 60 and going up to 1%. So let me actually tell you how this will happen in terms of, when you see those buildings which are actually done with these kind of products. So now we will have, now this facade is no longer going to be static. We know that we have seen a lot of static facades, and now you will have a solution which will be making all these facades go dynamic. So now the facades will have a higher performance, and they will be giving greater emotions. So you will have facades which can be actually controlled automatically. So this system as electrochromic glass can be controlled automatically, which already has its inbuilt system, and then it also can be integrated to the BMS. So you can have the BMS linked with this kind of technology, and then both of the technology, both the systems can be merged, and then the overall building will be performed the way it should be. So the way the sun is moving, so that's how the glass will be getting tinted in the direction of the sun. So imagine there is nobody who will be going to the glass window and then actually putting up the blind or pushing up the roller blinds by manually or by doing it with some servo motors. Now this will be done automatically, so there is no involvement, no human intervention which is required, and then people won't be able to feel that there is something which is happening to the glass at the first place, and they will be feeling more comfortable. And then to add to what you can do next to it, it can be also controlled remotely. You can have your iPhones, your Android phones, which can be actually linked up to this facades, and then they can control. So whenever you want to so imagine if it's a corner glazing facade, and you have used this kind of technology, which is electrochromic glass, and the sun condition is at the glass is going at 18% tinted state, but that may not be enough to do a projection. So once you want to do a projection, you almost want to create a night scene wherein you don't want to have a large amount of natural daylight, which you might require otherwise. So then you get through these kind of technologies and access to control it individually, and then control it the way you want. So you create a manual intervention. So by actually controlling remotely, or by having a button on the window or next to the window, will actually able to do a manual intervention. And as a technology, if you do a manual intervention with this product, this is actually going to stay for 2 hours, and then it will go back to its original state. So imagine that this is the level of technology which has actually gone ahead. So it will again go back to the automated state. So there is no one which is required to actually reboot the system and restart the system as an overall process. So now you will have a facade then wherein you can actually do lot of stuff without actually feeling that you are doing something. So this is, as a technology, is a new technology. So as a technology, it offers basic, more important 3 benefits to the consumers, to the industry per se. So it is about prestige and innovation. So the first pillar, what is being said as a technology, is prestige and innovation, because it's a new technology, it's a fascinating technology. It gives an exclusive experience. So it gives an experience of not interacting directly and going into the window. It gives you an experience of sitting at the back and then controlling what is happening to the glass, and then maybe it gives you an experience of differentiation. So this is about how this prestige and innovation comes with this kind of technology. Then there is a bigger pillar of comfort and in terms of the design. So we are talking about giving a heat gain control to the user, or to be done automatically. It gives free vision. So that's the more important thing which comes with this kind of technology, that your vision becomes free from any kind of movement of the sun or any kind of problem which are created through the sun of heat and glare. So you have a free vision throughout the day. It gives natural daylight, there is a glare protection which happens, and as a product, generally from the manufacturers, it comes as a laminated product. So it provides improvement in terms of the acoustic levels of the environment, and then it creates a silent situation. It's a simple technology. Yes, it's a new technology. It's still a simple technology, and then there is no maintenance required into this. So it doesn't need any blinds. So there is no maintenance. There is no moving parts. So it's like a maintenance-free technology. It can give you saving up to 40%. That's how it has been calculated throughout the studies. And then it comes, and this technology is actually being recognized from these institutions like BREEAM and USGBC. So if you actually do these green buildings, and if you go through the Green Building, US Green Building Council's website, you will understand that this kind of technology can actually give you up to 13 credits or 13 points by using this technology. So let us understand now in terms of how this can be made a case to talk about in terms of the commercials of this kind of technology, because since it's a new technology, yes, we are talking about something very new, but yes, it can certainly give you a payback. So we have to actually talk about in terms of how we can compare bundle costing as compared to differential costing for each and every product which we are talking about, the entire fenestration. So in terms of the conventional solution, we are talking about improving the lighting conditions, because you are now controlling the glass from outside, that how the light transmission is being controlled. Then you can actually also control in terms of your daylighting cost which is being spent, which is a large amount of money which is being spent in the interiors. We are also talking about improving the air conditioning efficiency of the of the overall building. So imagine that we are actually looking at in terms of using a static glass, and then you have your weather is not static, your climate is not static at all. So then we are talking about actually improving the overall dynamic air conditioning of the building, and we can have savings up to 60% in terms of the lighting and 25% in terms of the air conditioning. Then we are talking about removing all those shading devices in terms of blinds, in terms of louvers, in terms of internal shading devices, external shading devices, the blind systems which is being generally used, these automated blind systems, everything will be removed, and it will be only one glass which will be compared to the other solutions which are there for the fenestration. So we are talking about electrochromic glass, which is a one cost product, and then we are talking about all these differential products which are being used in the entire fenestration. So a general study which, if you see, has been conducted, and then how we actually look at in terms of the payback. So we are talking about this payback which is purely tangible. So this is not even the non-tangible benefits which are being offered by this technology, which is about the comfort which somebody will be getting inside sitting in a building wherein he don't have to hinder his views. He can see throughout the day, and he gets the natural daylight throughout the day. So those are the non-tangible benefits which a person is getting, and then these are the tangible benefits. So these tangible benefits are these productivity improvement, the energy and the maintenance benefits which is being passed on to the occupant, and then it gets you a payback within almost like some 4 to 5 years. So this is a study which has been proved, and then it has been it has made a large boost on the overall human productivity if you use this kind of technology. So in terms of the freedom of design, this product is available at a dimension of 3 meters by 1.5 meters. So imagine that you have a floor to floor height of 3.8, which I said. So you have a one vision panel, and then you have a spandrel panel which is like less than a meter of a height, and then you can divide the entire height into one vision and one spandrel panel. And then I told you, you have a technology which can actually divide this one vision panel into in-pane zones. So that also becomes very important factor. And then you can have one vision glass without any partitions, without any hindrance of the views. And then you can also do some amount of basic shapes like quadratic shapes, rectangulars, parallelograms and trapeziums, and even some amount of triangles you can be actually doing with this kind of technology. So just to put the things into perspective, how as a product or as a technology this can be actually put up in the buildings. So this is one of the project wherein this has been used as a product. This is not a fancy builders or a developer's office. So this is a school, Swiss International School in Dubai. So the agenda of the school was actually to showcase these innovations which are coming up in the industry and to use them to give the experience to the students. So this is a photograph of that project, and this is the facade. So in the vision area, so the sage glass has been used in the vision area, and in the spandrel there is a dark glass which is being used, which is a normal static glass. So if you see this vision glass, this is on a clear state, and in the clear state you can easily see even from inside, from outside to inside. Now this has 3 zones which you can't see now, and what I will do is I will show you how this picture actually changes when you introduce these zones in this picture, and this is how the facade is going to look from outside for this kind of technology. So when you tint the first zone, this is going to look like this. You tint the second zone, and you tint the third zone. So you see this is completely uniform from outside. You get 100% privacy from outside, and you don't find that there is a difference in terms of how the spandrel and the vision is behaving. So this is, you don't see shabby blinds, different colors, chart papers which is being put on the windows. So all those problems are being resolved by actually putting up the glass, as is this technology at the first place. So this is the outside view which you are talking about. More importantly is the view from inside. So that is what, as a technology which it offers, giving you a vision which is free throughout the day. So this is a classroom, and we understand that in a classroom with this amount of light, which is almost like 60% light, it will be very difficult to actually do a projection or do a classroom session. So there what you do is, now you can actually tint the glass, and it will actually become up to 1% light transmission. The important thing is that students can still see from inside to outside. So that's the beauty of the product. So this is a university project which we have done, EPFN University in Switzerland. So this is also one of a very good application for this kind of technology, which is an atrium area application. And I may tell you that these atrium area applications has been generally from an architectural point of view, architects would like to make this area very lively in terms of there is a lot of movement of the people they want to see from outside to inside. So to make that connection, generally they end up using a clear glass as a product, and this area becomes quite a greenhouse. And then because of that, you are not able to use this space as a particular space, and then there's a lot of air conditioning which is being pumped in this kind of application area. So we have this technology now available with us now, which can actually change the way the atrium used to behave earlier. So if you look at this area of application, which is an atrium facade, so generally you will be using a clear glass and creating a greenhouse effect in this area, and then this becomes a non-usable area for people. So then now you can actually have a technology of this electrochromic glass which can actually make this area usable. So if I show you how, then you can see now in this picture that how the glass has actually controlled this entire space, and this space has become a very useful space for anybody to have cafes here. You can do even computer screens here. So this entire space becomes very usable space for somebody to work upon and make this and even earn a revenue out of this atrium area space. The other application which can be also thinked upon in terms of using in this technology, which has been a little pain particularly for construction industry, has been these skylights. So generally what you will use in skylight is these sheets which are actually giving you diffused light, and then these becomes little shabby after an years, and then it is difficult actually to control, because then it's a static solution which you end up. And then the next solution is you use glass as a skylight, and then glass as a static glass which is used as a skylight, it remains at the same state. So imagine that you have used a glass which has a light transmission of 50%, so it is allowing 50% in the day. Imagine now the sun is directly falling on the glass, and then it creates a high amount of glare condition, and then you can't sit below the skylight. So imagine now if this could have been at a static glass, this picture if you see, if it could have been a static glass, it's only you can only have vegetables grown below this glass, you cannot have human beings. So if you look at this picture, so there are workstations which are not more than 15 feet above the glass, and then people are able to work easily. So you can, with this glass, you can actually control the skylight, and with this, if I change the picture, this is how the sun will be moving on the facade. So imagine that now this skylight will be completely controlled, and then you don't have to be worried about how the heat will be actually behaving, or how the sun is moving on the skylight. So you will have very high functional skylights with this kind of facade applications. So these are some of the applications and as a product which electrochromic glass can bring into, and then there are newer technologies also which are coming up.